Alright, welcome to my coordinate measurement machine. I'm using this to get the actual size of these plates because I don't have any other precision way, other than a tape measure to do it. So yeah, I'm just going to measure these, write down the dimensions, and then I will use a caliper to scribe a line for the amount I need to take off, which will be under 1/4 of an inch, so that's easily doable. And then I'll just machine up to that line later on. These are the plates for the top and bottom body extrusion, so they don't have to be. I really could do it with a tape measure, that would probably be just fine. But I would like them to be as close as possible to the actual size they should be. So I'm doing this. I don't strictly need this much dicum, but I don't use it very often, so when I do, I like to enjoy it. Let that dry for a minute and double check my print to make sure these are actually 12 by 12. I'm pretty sure that's what they're supposed to be. Alright, I don't have the greatest setup to do marking out like this, but I've never actually done it this way. I've always just used hand calipers, but I figure since I've got the height gauge and I've got at least a couple blocks, and these are so long, it's bound to be at least as accurate as doing it by hand. And again, accuracy is not all that important, but I figured I would just give this a shot. So let's see, we need to take 89 thousandths off of this side. That'll work. These were both drops from the same place. I presume they were cut at the same time for the same reason, so they should be the same size. Alright, and 2141 and 212 for the other dimensions. Very light pressure since I don't have any clamp or anything holding it upright. But again, could probably just do this with a tape measure and be, well, absolutely I could do this with a tape measure and be fine. But I could probably do this with a tape measure and be close enough. Nobody would notice. But again, just kind of having fun too. Alright. I think I'll mill on the Tormach. It'll do a better job. And it's got a reliable controls on it, so I can actually have it do the cut and not have to worry about it running off on its own like the Lagoon does. So I'll get that set up and we'll be back. That is probably good. Unfortunately, I can't, and the reason I was using the Lagoon before is I can't, my table only moves 9.5 inches this way, or 9 inches, I forget. Either way, it's not nearly enough to actually cut this, or, well, to machine it or to just measure it. So I'm going to have to machine the one side, and then turn it and re-square it up, and then machine this side, and then repeat with the other plates. It'd be nice if I could just move it over and have it overhang the edges a little bit and do both, but the machine's not big enough, and it's the biggest one they make. I had a feeling it wasn't going to like that, especially not this cast stuff. Which is why I always use coolant. But I wanted you to be able to see. Alright, I am going to pick these little bits out, set things up because it moved a little bit, and then I'm going to run it with coolant, and we'll be back when I'm done with that. Alright. So the plates are all done, 12 inches by 12 inches, nice and square. And now I need to machine the features onto these. So I can't measure, I can measure this distance to get the center. I can't measure this because that's out of the travel of the machine. And actually, now that I'm looking at it, I need to move this plate so. Son of a bitch. That is the fan recess and the counterboards for the power supply. Now I need to do some through holes, and because you can't do that with vacuum, I am just going to spot all the holes and I will drill them manually later on. Alright, this center section needs to be cut out. I'm going to try to get as close as I can to poking through. That way it's easier to both pop out and I don't have really thick stuff I have to try to deburr from the other side. We might end up poking through. This should be about 10 thousandths, 10 or 20 thousandths, I forget. But under that thickness, it starts to get really floppy. They think like aluminum foil in the kitchen. And the cutter wants to suck that up, and all it takes is the tiniest little hole and you lose all your vacuum. So I've got the clamps on, and we're not doing anything that's going to move this workpiece, so I'm not worried about it. If it pokes through, it pokes through. I've got my my coolant separate, or what would you call that, coolant trap, I guess, on the vacuum line. I always use that. I've had far too many instances where you don't necessarily poke through something, but you might have a seam in your gasket that's a little off, or who knows what. And I've had a lot of times where that little vacuum, Venturi vacuum thing will fill up with coolant and it'll lose vacuum, and then it's bad. So I always leave that thing on the vacuum chuck website. They talk about it taking, extra, they even say like a few minutes to draw a full vacuum, because you got to suck out that container as well. I don't notice any difference in the time it takes to draw a vacuum. If it is some sort of difference, it's less than 10 seconds probably. So it's never concerned me. I just always leave it on now. And I've come out to the garage more than once to see that thing 3/4 of the way full of coolant. So it's well worth getting one of those. Actually very surprised. That's pretty cool. Check this out. You can see the force of the atmosphere. You got coolant on the lens. The air pressure. Can you see that? Right in this ring, you can see the pattern of the vacuum chuck underneath it. It's starting to suck it down, and that's where that's another way you can get into trouble, is if you get really thin and the force of the air, oh, see, I just poked through it. All it takes is this tiniest little divot, if that tries to suck it down into one of these holes or gaps. All right, and so that's good to come out. I do have to manually lay out another 4 drill and tap holes for the feet. This machine doesn't have the travel to get to the 4 corners, so it's not a big deal. They're just for the rubber feet, and they don't really need to be anywhere in particular, but I'll just lay them out with calipers and drill them manually. There's our a nice little foil pop out thing. Alright, just a light deburring, and then we got to lay out these other holes. Alright, we're back at the bench. This is where the fan grill will go. The fan will be, this is the bottom of the machine right now. So that the fan will be underneath. The feet should give us enough clearance that this can still suck in a decent amount of air. And then the fan, regular 120 millimeter fan, will be on this side. I don't know how much cooling it will actually need. In my experience, the ClearPath motors really don't generate much of any heat, even being used on the CNC machine, where it's constantly pulling a lot of current to start and stop. Maybe it's just the heatsink is dissipating it very well, but I've on more than one occasion just reached out to touch the motors just to see, and they're always pretty much just room temperature. So I don't know if we need the fan, but I'm going to put it in anyway. I already have a bunch of extra 120 millimeter fans, so it's no big deal. feet holes is what we need now. Let me go see what dimension those are. Alright, they are 0.788 for some reason. I presume I had a reason when I picked that, but who knows? Alright, my cheap calipers batteries are completely dead now. So I'm going to 0.788. This feels dirty. Yeesh. Alright, so this one should be all done, except for the manual hole drilling, of course, and tapping these. These don't get tapped, and these don't get tapped, so I just have to tap these feet holes. But we'll do that. I've got some other manual work to do on the other plates, I'm sure. So for now, I'm going to set this aside and we'll work on the next one. Alright, let's start assembling. I've actually already done this portion of the frame, and I actually did this portion already as well, but the hard drive I was storing the footage on decided to die, so I don't have any footage of that. I also don't have footage of making these cubes anymore, but they're pretty simple. It's just a cube of aluminum, drill a hole in 3 of the faces, countersink down inside, and then bore out the top. So you have a corner piece that can connect these extrusions. So you just put them together like this, just making sure that you've got a big hole every direction you need a screw to go into. So be this way, make sure this one's right, be this way, and possibly this way. No, this way. Alright, and then I want to make sure I've got these pieces. These I machined up. I don't think I've got any video of them. They're fairly simple. It would be simpler if I had a lathe, but I just machined this side, took a big block, machined the top side, put them in a pair of soft jaws, and then machined this side. So nothing too hard there. These will go in the top like this. Actually, I know one of these, I've already test fit them, one of these cubes has a bore that's slightly smaller than the others. There we go. And so slightly larger than the others. So I made one of these to fit snugger in that one. More snugly in that one. So this should go here. Alright. So we're good like that. Yeah, and then these just rest inside in the bore of one of these cubes, and that's what will hold our top plate that we've just machined. But let's get this together first. So you just put a countersunk bolt in there. While these things are neat and very good looking when they're done, they can be a little bit of a pain to get a screw in there. It'd be less of a problem if I used a longer screw. These are really quite short, which is all you need, but curses. Alright. I'm just getting them in here a little ways, so I'll tighten them all up once it's all together. Which is generally a good way to go about these sort of things. Yeah, I didn't figure we needed to take that other frame apart. If you watch me put this one together, it's the same thing. I did have a trick for putting these I think it was that for putting these together before, but it's been a couple of weeks. Yeah, it's probably been a couple of weeks since I first put that together. Alright, I'm going to double check one more time to make sure all of these fit before I commit. All these holes should be more or less the same size, but since I didn't want any slop in these, since they'll hold the top plate, I did several steps of machining, getting them closer and closer until there's, probably can't see it from that far away, but there's, I don't know, maybe half a thousandth, something like that, of play. There's not a lot. Alright, and now, since I cut these all square, they should just bolt together into a nice square frame. And then once this whole assembly is put together and we get the side plates on, which I haven't even started yet, those will kind of brace everything together, and then I'll go in and actually tighten all of these completely. Right now I'm just on setting 11 or so on the drill, so it's enough that they won't move around, but alright, so that should be all nice and square. So we've got our two frame pieces now. I guess we'll start at the bottom. So on the bottom of this, we have our plate with the fan cut out. So this will go, was that right? Is this the bottom? Let's see, so I've got big holes on the top and the bottom, so I guess it doesn't matter which way is which. Either one's the bottom. Alright, say this is the bottom. I'm sure there's probably a reason this isn't the bottom, but I'll find that out later. Yeah, should be good. So, first, use our T-nuts, our roll-in T-nuts, or I guess they're not T-nuts anymore, but they're roll-in some sort of nuts. And those, as the name implies, just roll in to the channel here, and then they've got these little ball bearings on there, pressed in spring-loaded ball bearings that kind of hold them in place. Not particularly well, but generally enough that if you normally if you put a T-nut in there and then you go to stand it up on the end, as long as you're careful, they'll stay in place. So they're a little bit more expensive than the cheap T-nuts, but they're well worth it if you are the type to spend a few extra dollars to not have a hassle. There are also a type I've used in the past at the old job. They have a rubber kind of plug instead of a ball bearing. Those work okay too. These are just whatever I found on Amazon. Alright. Debating now, do I want to put this on? Well, we'll put it together. I really probably should put the power supply in here first, and the fan. Alright, we won't put this on just yet. I will put the feet on. A whole bag of feet here. Because they, oh, those are some strong smelling feet. Yep, they smell like rubber. know what? I'll put this base on now. It's easy enough to take off. I probably will have to later. But we're just building up the skeleton of the thing right now. Make sure it all goes together. So get our feet in. The fan filter will go here, but I'll put that on when I put the fan on, because it's a three-piece piece. You've got your guard, your filter, and then I guess this part that it clips onto, and then your screws will go through here, through the fan, and then a nut on the other side. So when I get the fan installed, I'll have to go into the supply closet here in the house and find an old computer fan. I've got plenty of them laying around. These same flathead cap screws should do fine here. That was the plan anyway. Let me get these lined up a little bit better. Where do I have... There we go. Yep, this is the step where if you buy just standard T-nuts, you'll be wishing you had bought these instead. These, once you get them in place, as long as you're reasonably careful, don't go banging it around, these will stay in place. So I need to move this one and this one. They've got a tiny little lip. You need to make sure if they're just floating in there, they'll slide all around. You have to actually get them so the flat side is up against the flat side of the extrusion before they'll stay put. Alright, all lined up. Why are you being difficult? Ugh. If I had to guess, I would say it's probably the Amazon nut, not the McMaster car bolt. That's the problem there. When I say they're a little more expensive, they're still cheap. I think a pack of 25 is like, I don't even know, $15, $10. So this one is probably got a messed up thread. Might have actually been the one I picked there was still a chip from the thread cutting in there, in one of these, that I picked out while I was putting it in. Might have been that one. Let's try this again. Everything's still in place. Is this spot cursed? What's going on here? It's definitely lined up fine. There we go. Probably could have done with some longer bolts, but I wanted to use the same bolts just because I guess I was being cheap. The sheet metal for the sides is quite a bit thinner than this stuff, and if I got any longer bolts that would have fit well here, I see what's going on. These sometimes are rolling slightly sideways, and these are just, I mean, they're long enough to work. You can see they're touching there. They've still got maybe a quarter, probably a little less than a quarter inch they're going in. So it'd be plenty to hold this thing together, but anyway, I wanted to use the same bolts for the base, and I wanted to use the same bolts for everything. It was just easier that way. I say it was easier that way. It's proving to be a little less easy. Alright, I'll come back to that one. Alright. There we go. Alright, so that's a base. Got the nice rubber feet. Good and solid. These all still need tightened up once it's all put together, but good deal. Alright, so now we have the plate that holds the motor. That will go in here like... Actually, that one I remember now. That one actually gets bolted to this way. Because these, once again, all fit in here, right? Yep, so those go in there. These don't get bolted in or anything. Those should just, because there's no real force pushing it in any real direction, at least I hope. Those will be able to hold everything in without being fastened in any way. Let me move you up here a little bit since we're higher up. There you go. Alright, so this gets bolted on to here, and I've hopefully designed this, well, I've designed this in the hopes that it's fairly modular to come apart and go back together. So I should, if I, I need to replace a small part or something, I don't need to disassemble the whole thing. Just take a few bolts out and be good. That's the idea. Now these actually have, I don't know if you can see there, they've got little grooves in them. When they're put in the channel, you roll them in like this, and then the good ones that I've used before, this is this center part or these edges, either this sticks up higher or these go down farther, so they, show you here, so they, see that one hasn't been rolled in yet, but you can see they kind of are supposed to line up and just kind of pop into the channel here. And these aren't really doing that, so they don't work as well. But like I said, they were the cheap ones on Amazon. They are probably 20% the cost of the actual ones from the aluminum extrusion suppliers, the big name suppliers anyway, 80/20 over here. These are actually metric extrusions. I got them off of the same machine that this big aluminum workbench is made from, and the DIY CNC steel came from. It was a gigantic automation machine that ended up being scrapped because it it was just going to be more, it was going to cost more to try to salvage. It wasn't working properly, whoever originally made it. And it was like $1 million machine, but it was going to end up costing more to try to salvage what was there, you know, and build around the components that they had picked out and all that stuff. It was going to be cheaper to just build a new one from scratch. So they ended up scrapping most all, I don't know why I took that off. They ended up scrapping most all of the machine, including all the frame parts and everything else. So that's where all this stuff came from that I'm still using now. Bought it all for whatever the price of scrap was at the time. Which, if any of you take in scrap metal to the scrapyard, you'll know is not a whole lot of money. Especially steel. I think, see, at the time, I think the steel for that was somewhere around $75 a ton, something like that. So all of that plate, all that 1-inch thick steel plate that makes up that, and then I'm storing more of it, you can't really see in there, underneath the machine, all of that stuff, and the plate that is now this workbench top that I'm working on, all came from that machine, and was probably, the aluminum was, you know, aluminum sells for quite a bit more than steel, scrap price anyway. I might have paid $150 or something for the whole lot of aluminum, and like I said, the steel, like $75 a ton. There wasn't I don't think there was a ton of steel there, so it was exceptionally cheap. Unfortunately, it comes with a whole bunch of holes and things already in it, odd shapes, you know, so you kind of have to work around it. But if you don't mind, you can get a pretty good deal on scrap material. I know you can check out the scrap yards. I know at least one around here. You can walk the yard and you can basically buy the scrap from them for pretty much the same price they paid for it, probably a little bit more. Basically whatever price that the refiner is going to give them. So if you don't mind cutting around stuff and working with odd sized pieces, you can get pretty good deals on metal that way. And a lot of the times you don't know what exact grade it is. It obviously doesn't have any certifications or anything like that. You know, so you don't use it on anything important, but you know, for little shop projects like this, it's nice. All right, so now the motor, we can put the motor on this. That goes in this way. Right? Yeah, of course, because the recess is for this. And I just tapped these, but I already don't remember what they are. 1024, I think. One thing I could definitely use is a much better selection of hardware. Why do I have security torques? That's an odd... I would have never bought security torques. I don't even think I have the bit to take those out. I wonder where I got those. Alright. These the 1032 or 1024? 1032. Good. And these... yeah, they're a little short. Those security Torx ones are actually perfect. As far as things that I have, let's see if I've got the bit. I did buy a set not too long. Maybe that's where I got this set from Vega. All sorts of little, all sorts of little bits. Maybe I bought this specifically because I had something that had security Torx. And it's got security bits in there. Yeah, there's security Torx bits. Well, I guess I'll use these. I don't really want to, but on the other hand, because of the way this thing comes apart, I doubt I'll ever have to take the motor off this bracket again, so I might as well use them up here. It's not the best driver, but it'll work. Nope, no, it won't work. Release. I'm going to need a really long driver for this. I don't think I have anything. Well, this is my least favorite way to do anything ever, but I guess we don't have a choice. I'm going to have to thread them in and then use the wrench. Which is just the worst way to have to do these, but I don't have anything that's any sort of driver that's going to be this long. Come to think of it, I don't, regardless of what head these had on them, I don't think I have any drivers that are that long. I have one Phillips that's pretty long, but I don't think it's that long. This is terrible. Ooh, I do have one of those flex shaft things, but it's only going to get me this far, and it's actually it won't be big enough for these. Didn't have this problem with these motors on that machine over there. They're only, looks like about that tall, so that wasn't too big of a deal, evidently. Right. You know, I realized I just forgot, or I just remembered that I had forgot to put something, this is the piece that mates onto the motor that'll actually turn the platter with the magnets on it. There's a key on this shaft, and I haven't decided what I want to do with this thing yet. If I want to try to, because I don't have a broach or any way to make a key slot in there. I was thinking I'd just put a screw through the side, but that seems awfully, you know, I mean, I'd like to use the key, even though it doesn't need it. There's not going to be a, I don't know, just seems, I'd like to do a key, but it's just, I think, going to be too difficult to try to do with the machines I have here. So I may end up just drill and do a set screw, but I guess I'll take that off later and do it. Okay, so this piece will fit like this. Now these, the top and the bottom here, will be held together by the sheet, thick sheet steel that goes on the sides. I think this is actually for the front and back, but you get the idea. I'll have 4 of these on each side, and that will bolt with more T-nuts and these bolts. So that will be just fine. And I went with that big, thick, heavy stuff because that is what the handles will go on. So the handles will go here so you can move it around. So I needed something thick enough that, you know, you could do that with. All right, so this guy and this guy go together. And that's a nice snug fit in here. This is kind of the drive key, I guess you would call it, and drive lug, something like that. So there are screws that hold these 2 plates together, but they're not taking the load. It's this fit here that's going to do that. So this needs a little bit of persuasion. I've test fitted this as well, and it's nice and tight, which is the way I want it. Sometimes the holes in these benches come in handy. And then the screws will pull that together the rest of the way. Speaking of them, where are they? Here they are. These should fit. Appears they do. These same screws will be used for the magnets. Which I'll go get the magnets. We'll put 3 of the magnets on. The 4th one I had a little incident with, if you saw my other video. They were separated by a one of the interior doors in my house. I had 2 on each side of the door, and they were, you know, hanging on the door through the magnetic field there. So the idea was that was holding them in one place together with, you know, sufficient. What's going on here? Why are you being like this? Are you not all the way down yet? Anyway, taking them apart, they slammed together and lost one of them. There we go. So I had to order a new one. These could do with being just a little bit longer. Let me see what I've got. No. Nothing that'll work there. Unless that's not in there fully yet. Oh yeah, that's definitely not in there straight. That's what the problem is. Probably went with a tighter fit than I really should have. There we go. Let's try this again. See if it fits one way better than the others. It seems to fit this way the best. I need a something. I need a tube that I can put around this. A large socket, that will work. Maybe? No, it will not. Maybe this socket? Yeah, there we go. Why are you not wanting to go in straight, Chief? Seems better. 484. All right, it's in there straight now. I was going for a tight fit, not quite that tight. These bolts are looking a lot better now. They should go just through the bottom of the plate. At least that's the way I designed it. They should be flush with the bottom when they're fully tightened. Yep. And I guess I don't have to worry about this thing coming off in use. That's how hard it was to get on, but now that's more or less one solid piece. Oh. Alright, let me go get the magnets. I'll move this thing out of the way. We'll see if I can't injure myself. Alright, so here are our big magnets. Are these magnetic? Not magnetic stainless. Pick off the pieces of the old magnet. And these are, well, they're not quite, they probably wouldn't hurt you too bad. They're definitely some wicked magnets. Come on. Ah! Whoa, what are you... There must be a bolt under there. Is there? Oh yeah, one of the bolts that holds this tabletop down. Yeah, they're no joke magnets. Fortunately, these are non-magnetic stainless steel, so that will make this a lot easier. Forget how many pounds these things are supposed to hold, but it's a lot. I'll just put the other magnet on when it gets here, and we'll just pretend we did all 4 today. Come on. Stop it. Stop it. Alright, now to be careful. Ugh. Oh boy. No, they might probably wouldn't break a bone. But it certainly probably hurt. Gonna have to go quarantine this plate when I'm done. Put it somewhere safe. I am gonna have to take that back apart though to do the key or whatever I decide to do on that shaft, but I'll do that separately. Try to remember to let you know what I decided. Probably end up just doing a set screw, it'll be good enough. Come on. Alright, so we'll have one more magnet here. And hopefully that will end up being balanced when it's all said and done. I may have to balance this wheel. Alright, so that goes on here. And then this should, I can't see, hopefully this sits down on that motor shaft. It's supposed, let me think. It is supposed to sit, these magnets should be flush with the top of it, or a little bit below the top of this. It's acting, I can't see through the side of this, but it's acting like it might be up a little high, and I'm not sure why that might be. Let me double check the drawing here. Alright, so that is supposed to sit quite a ways down on that shaft, a lot farther than it's sitting right now. I will have to check and see if, well, we'll check this here. .125, which is probably right where it should be. And this from here to here is 0.983, 1.16. So that, right, 1.16 from there to the very bottom, 1.159. So that may just need forced onto that shaft a little bit further. And actually, thinking about it, I am going to have to thank you, the oiler, automatic oiler for the Tormach. I am going to have to take this back off to put the set screw in, or whatever I end up doing. That's partly why I want to do a key, because I don't want to have to try to get a very long Allen wrench or something, you know, because I got to get all the way to the center there. Truth be told, it probably doesn't. No, I got to put something in there because it's a snug enough fit, but it'll start spinning. I get the feeling if I don't secure it somehow. Oh, don't pick up the old pieces of magnet. Let's see, let me take this off. Now if I'm careful with that, all the T-nuts should stay. Are these magnetic? No. Alright, so the bottom of this should sit just underneath the plate there. So it's not yet, but I get the feeling it may just be because I had to machine this on the mill. As the end mill gets deeper and deeper into that, deeper and deeper into this, it'll start deflecting more and more, so you'll have a wider hole at the top than you will at the bottom. And it may simply be it's just slightly. Oh yeah, no, that goes on just fine. Hey, there's metal in my hammer. Yeah. Yeah, no, that's just fine. It's probably a little tight now to get off. See, that's what I was thinking. It almost doesn't need a key. This is just gonna spin. But I don't wanna risk it. Well, I may have to now. Release. Let me think. Let go! I can get a bar under there and pry it off, but I'd rather not. I'd rather you just come off. Well, this is good practice for if I have the Allen key that I'm supposed to try to get. No, I guess I can reach it from here. Stupid magnets. I'll have to remember, I'll take the magnets off and put them on later. I've got these long, these guys, are these, yep, they're magnetic too. I can get in there, no problem with that. Alright, so that's not bad. I will put a set screw in. Yeah, I'll get a set screw in there. We'll just do that. I'd like to do a key, but what are you going to do? So I'm just going to get this thing back off. I think. Well, I didn't use that much force to get you on. I think, yeah, taking that off won't help. Not on that tight. I don't want to put too much stress on the motor bearings either. I'm kind of going gentle with it. At least I know once it's on, it'll be on good. There's really not wanting to come off, huh? Well, I'll work on that off camera. So, this goes on here. Yeah, I could definitely use some longer bolts here. It's pushing the T-nuts down to the bottom of the channel, where then there's not enough, you're only getting like half of a thread. So it's just barely making it in, but then it's getting pulled out. Come on. Be less awful. Alright, I'll deal with that one separate. Okay, but now that this is on here, I just want to show you guys how this thing goes together. So we got this. And this goes on the top here. Electronics will all go down underneath. The sides will hold everything together. Then these guys go on top. And these will hold the top plate on, because obviously you can't set a bucket onto here and expect it to stay in one place. Oh right, this one has the one, there we go, the one different one. This part that we just machined will go on the top here. And then this piece, I'm trying to remember, I think I decided this one I was going to, well, not strictly necessary because it's not really going to go anywhere now. I'm going to, was I going to do that? I'm trying to remember. I think I was just going to leave this here with, because there's no, you're just going to be setting something on top. It's not going to be, there's nothing that's going to be trying to lift this up or anything. And it's in there pretty good once you've got, because I got nice close tolerances with all these. Once it's in here, it's kind of all wedged together. So it's not really, you know, I mean, you can pull it out, but you would never do that in real use. I'm trying to think. I don't know, maybe I'll put in 4 countersunk screws and some T-nuts just to hold it down. Doesn't strictly need it, but yeah, there you go. I'll sit in there and spin. Set your bucket on top. And then I've got the orange plastic Nice bright orange plastic, clear plastic. That will sit on top of these little posts, and we'll have a hole cut out for it that fits the bucket so that the bucket doesn't, you know, wiggle its way off the side. This will kind of be a ring to hold it in. But I don't want to machine this yet because I don't know what size bucket I will want to go with. So I will do that later. And for now, I will just, I'm not really sure how I'll hold something there, but I have to do some experiments and just see what size works best for me. The idea is a bucket that's roughly the size of this platter diameter, but never used one of these before, so I don't know if I want a smaller bucket or a bigger bucket or what. So yeah, I guess that's it for now, other than the electronics. And I will probably put this video out because it's been a while since I've done an update on this. While I machined those side panels, and I was planning on getting them powder coated or something. Really not too expensive, and it'll look really nice when it's all done. So that'll take me a little while. Got all the electronics to put in. I got the magnet I'm waiting on. That should be here this week. Yeah, I guess we'll just end it there for now. And we'll be back next time to get it all put together. Yeah, you can see it's kind of, it's not quite flush yet. That's why all these bolts will get loosened up a little bit. Everything will get shimmied into place and then tightened down and get everything nice and square to each other. Because in theory, it should all be good. Everything has been machined square and straight up to this point, so it should all go together nice. Alright, we'll see you next time. Take it easy.